So we're looking at log scales today. Now log scales increased by a factor of 10 magnitude. So we use them to showcase when we want to compare numbers that are separated by a really large amount. We use log scales. So not always used, but there's definitely fields where we like to use these, and I'm certain that you'd be familiar with a few of them. What might be some contexts where we would need to use a log scale in the real world? James?
The Richter scale.
The Richter scale, very topical right now given what's going on in Turkey.
What's happening in Turkey?
I like that you can tell me the latest TikTok craze, but you can't tell me about the rather large world
I
event.
haven't had time to watch the news.
Haven't had time to watch the news, I've been too busy on the phone. Breaking stereotypes about young people. There's two more. Two more commonly used scales. What's that? If you don't know this, people might say that you've got a very high reading on one of them.
IQ.
Not quite.
IQ.
No, the pH scale.
That doesn't increase by 10.
No, I'm saying the number of H ions, H plus ions.
I thought pH was only between 1 and 14.
No, it is between 1 and 14, every level. So like the Richter scale, obviously let me explain this a bit. The Richter scale, if you increase a reading by 1, it's actually signifying a multiple, a 10 times larger earthquake. So the difference between a 4 and a 5 is the 5 is 10 times more intense than the 4. And the 4 is 10 times more intense than the 3. Which means if you go up 2 levels on the Richter scale, you're increasing by a factor of 100 times. Cool? Now on the pH scale, for those of us who didn't get my joke, some people might say that you've got a high score on one of this. I'm implying that people might think you're basic if you didn't know that the pH scale was, hey, chemistry jokes, how was that? And interestingly, they'd be telling you this through sound which is measured by the decibel scale. Are you sure you didn't read this before you rocked
What
up?
scale is that?
I did it yesterday, you gave it a word.
I did too. This is the problem with keeping you in front of the class, James. The decibel scale is the sound scale. So now, unlike the Richter scale, which every 1 level we increase, the decibel scale is tens. Every 10 levels you go up with the decibel scale, you are increasing by a factor of 10. Cool? So if you've got a decibel 120 and 130, the 130 is 10 times louder than the 120. Are we happy with that? Cool. So the one we're going to focus on today is the Richter scale, partly because it is, I would say, the most commonly used scale that we are familiar with numerically, and it's nice and simple. So we're going to look at 3.5, question 1 to 4, but we're going to start by looking at question 1. This is the equation for our Richter scale. And that's our equation. Why must it be log base 10?
Because it's going up by 10.
Every time we go up 1 level, we increase by a factor of 10. So the base tells us about that. 10's a nice number to go up by because we use it for scientific notation, we use it for all sorts of things. I don't know.
Is that an I on the top?
It is.
And what's on the bottom?
I naught. Now, we need to be really across our scientific notation with significant figures. I'll talk about that as we go through, particularly scientific notation. We'll do the first question and we'll talk about scientific notation. So, the first question asks us to determine the intensity in terms of I naught of an earthquake that has a Richter scale reading of 8.2. So like any question, we write down what we know. We know that R equals 8.2. Now we don't know what the intensity of a baseline earthquake is. We don't need to know. We just need to know I in terms of I naught. So our answer should have I naught in it when we finish up. I'm going to write in what I know. So I know that R equals 8.2. And even if I knew nothing about logs at this stage, I reckon most of us could identify the next step. So I want you to think for 5 seconds, what is the next step in this problem? Rebecca, what do you think the next step is?
Is there meant to be a word after out?
Yeah, I rubbed it off so you didn't get the... Now that you're finished...
Intensity of out.
Oh. EQ. EQ.
What's EQ?
Earthquake. Or Education Queensland, depending on...
So like intensity of the out thing.
Yeah, the intensity of our earthquake versus the intensity of a threshold earthquake. The threshold earthquake, don't worry about the amount of joules, it's just our baseline earthquake, something we use to compare earthquakes. So here, we've got 8.2 equals log 10 I over I naught. What do we think, Rebecca, our next line of working would be?
Getting the I more to
Yeah, we want to get rid of the log 10. I'm going to the I and the I naught by itself. So how do I get rid of the log 10? Not natural log. What's the opposite of log 10? How do we cancel that out? Pardon? Wow. Ethan. 10 to the power of. I'm just going to put 10 to the power of down below. That's going to cancel that out. Cool? So we have now 10 to the power of 8.2 equals I over I naught. Now, this is the really hard part. All we have to do now is go to our calculator and write 10 to the power of 8.2 in. Yes, rattle them off.
1, 5, 8, 4,
Keep going. No, keep going, Max. I'm not done.
8, 4,
No, keep going. Make a point.
yeah, it's just a big number.
I know. So the reason we use this is because we don't represent really long numbers. It gets a bit tiresome, correct? We get a bit lazy. So Max's reaction there is exactly why we use this process. Now, I'd written this in before Max had started writing, saying numbers, correct?
Yeah.
How do I know that?
Could be.
Pardon? Not particularly. I'm sure there's plenty of people that'll tell you, give you that.
Because the Richter scale was 8.2.
Yeah, 8.2. So the first number before the decimal place tells me what the power is going to be. The decimal place tells me how big this number is going to be. Cool? When we're writing scientific notation, we must have 10 to the power of a whole number. The whole number can't be more or less than the first value in that, can it? So if it was 6.3, I'd know that it was going to be 10 to the power of 6. If it was 9.28, I know it's going to be power of 9. If it's 9.87, I know it's going to be 9. Cool? The 0.87 being bigger will change this number. Are we good with that? Or not? Have we seen scientific notation before? Are we relatively proficient in using it?
Yeah.
We'll need to be good at using them on a calculator. How do I get rid of I naught? Times both sides by I naught. I get I equals 1.58 times 10 to the power of 8 I naught.
But are you dividing that side by IO?
Am I dividing this side by I?
Yeah, the right hand side.
I times the right hand side by I.
So how does it cancel out? Wouldn't it just...
Well, it was divide by I.
Oh,
Now in question B, it asks us much the same question, but it asks us to compare that earthquake to an earthquake of 5.1. So the first thing I want you to do, I'm not going to write out where you're working. I'm just going to give you, I'm going to call this IA. I'm going to call that one IB. To compare them, what should I do? What should my last line? If I want to compare IA and IB, What do you reckon my last? I'm just going to call it K. K should equal. Not take, because we're dealing with number of times larger, it's IA divide IB. Cool? And that will allow us to compare how much larger IA is to I2, IB. We know that IA is going to be bigger than IB. How do we know that initially?
Then it has a bigger Richter scale.
The Richter scale value is bigger. How much bigger would we expect? It's always good to have an idea in our head. Over 1,000, it's going to be 3 levels higher, which means 10 to the power of 3 bigger. Sweet. Let's rock and roll.
So that's the final answer for 1A.
Yep, that's the final answer for 1A. It is 1.58 times 10 to the power of 8 times larger than the threshold.